Good morning, everyone. The last period we talked about scientific notation and the properties of A powers. Now we will make an extra exercise. Part A, we have simplified each of the following expressions. X power 3 over x power 2 times x power 4. We should use here in this exercise the rules of the powers. In the numerator, we have only x power 3. In the denominator, x power 2 times x power 4, we have multiplication of same base. We add exponents. 2 plus 4 is equal to 6. Now we have division of same base. We subtract exponents. The numerator minus the denominator, x power 3 minus 6, it is equal x to power minus 3. And we can write it as 1 over x power 3 to have positive exponent. Of course, the last step is not important. Here we have 2a power 4 times 3a power 6. We multiply the number by the number and we add exponents of same base. 2 times 3 equal to 6. A power 4 times a power 6, we have a power, we add exponents, a power 10. Here we have two exponents, 2 over 3. If we have two exponents, we multiply them. 2 times minus 1, it is minus 2. Now, we put this exponent to the numerator and to the denominator. It becomes 2 power minus 2 over 3 power minus 2. And in another way, when we have negative exponent, we can reverse the fraction and put it directly as a positive exponent in this way. It becomes 3 power 2 over 2 power 2. Then the answer is 9 over 4. And if we use this way, now we move the numerator to the denominator to have positive exponent and the denominator to the numerator to have positive exponent. 2 power minus 2, it becomes 2 power 2. 3 power minus 2, it becomes 3 power 2, and we'll get the same answer. Part B, write in scientific notation. The steps used in scientific notation are: first step, if we have decimal numbers, we get rid of the decimal numbers. Second step, we simplify numbers alone. In this example, we have 9, 7, 21. We simplify the numbers alone and the powers of 10 alone. Example, 9 times 7 over 21. If we can simplify before multiplication, we make simplify. 21 and 7, we can divide here by 7 and here by 7 equal 9. 7 divided by 7, it is 1. 10 power 10 times 10 power 3, it is 10 power 13 over 21 divided by 7, it is 3. 10 power 14 times 10, of course 10, it is power 1, not power 0. 10 power 14 times 10 power 1, it is 10 power 15. Now, we simplify the numbers together. 9 times 1 equal to 9. 9 divided by 3, it's equal to 3. 10 power 13 over 10 power 15. We have division of same base. We subtract exponents. 13 minus 15, it is 10 power minus 2. In another way, if we move this 10 to the numerator, it becomes 10 power minus 15 Now we add exponents. 13 minus 15, it's equal minus 2. Now the question is scientific notation. We should revise scientific notation, which is the number should be between 1 and 10. A should be between 1 and 10, which is correct here since 3 is between 1 and 10, and 10 power minus n is an integer. We have minus 2. Then this form is correct, and in this way we have finished. Second example, we have decimal numbers. First step, if we have decimal numbers, we should get rid of decimal numbers in order to calculate easily. 3.14, we will move the decimal point in this way, one step to the right. It becomes 34 times 10 to power minus 1. 10 to power minus 3. 5 is not decimal without decimal point. Here we have power of a power, we multiply exponents, it becomes 10 power 6. In the denominator we have 0.4 equal 4 times 10 power minus 1 times 10 power minus 2. Now this way becomes as the first example. We take the numbers together and the powers of 10 together. We can see that 34 can be divided by 2 and 4 can be divided by 2. It's equal 34 divided by 2, 17. We have 5 here times 5. Powers of 10, minus 1 minus 3 equal minus 4. Minus 4 plus 6, it's equal 10 power 2 over 4 divided by 2, it's equal to 10 power minus 1 and 10 power minus 2, it is 10 power minus 3. Now we can't simplify anymore. We take the numbers alone. 17 times 5, it's equal to 85 times 10 power 2 over 2 times 10 power minus 3. We take the numbers together and the powers of 10 together. 85 divided by 2, it's equal to 42.5. If we move 10 power minus 3 to the numerator, it becomes 10 power 3. 10 power 2 times 10 power 3, it's equal 10 power 5. Here we should write the answer in scientific notation. Then this number is not between 1 and 10. We should move the decimal point to the right or to the left in order to have the number between 1 and 10. It is 42, so we should move the decimal point to the left to become 4.25. We move one step from right to left, revise the last period, we multiply by positive exponent, and we have 10 power 6. So the answer is 4.25 times 10 power 7. Now we have set of numbers. Set of numbers, we should revise quickly each one. First set is natural number, which is n, symbol is n. Set n is the set of only positive numbers, which are 0, 1, 2, 3, 4, etc. Integers, they can be positive or negative. Z symbol, minus 2, minus 1, 0, 1, 2, 3, etc. It can be +1 or -1, +2 or -2, +3 or -3. Decimals. Decimals, what do we mean by decimals? Which is the decimal part ends. Example 2.1, 3.75, 0.321. These are the decimals. Non-decimal, the decimal part doesn't end. And we have two cases. Decimal part doesn't end, and we have two cases. It doesn't end, but it is repeated or not repeated. What do we mean by repeated? For example, 0.1111, etc. It's equal to 0.1 bar. This is the symbol of repetition. Or 0.252525, etc. It is equal to 0.25 bar. Here we have one digit is repeated. Here we have two digits are repeated. Not repeated decimals. Example, pi. Pi, we know it as 3.14, which is 3.1415, etc. The numbers don't end but not repeated. Another example, radical 2 equal 1.4142113, etc. These are not repeated. Here we have repeated. Rational numbers. Rational numbers. What are rational numbers? Every number that can be written in the form of a over b, where a and b are integers. For example, we can start by natural numbers. Natural numbers, example 3. We can write it as a fraction because 3 it is equal to 3 over 1. Then every natural number is rational number. Integer in the same way. If it is -2, we can put it as -2 over 1. It can be written in the form of a over b. Then every integer is a natural number. The decimals, example 2.1, we have only one digit after the decimal point. It is 21 over 10. If we have two digits, 3.75, two digits after the decimal point, it is equal 375 over 100. So every decimal number is a rational number. Repeated, example 0.1 bar. Here we write 0 plus 1 over 9. Over 9 because there are only one digit repeated. If we have two digits, 0.21 bar, it's equal 0 plus 21 over 99 because we have two digits. 2.1 bar, we put the whole part alone, 2 plus 1 over 9. Of course, if we want to continue this example, to write it in the form of one fraction over 1, we make same denominator and we continue. 2 times 9 equal 18. 18 plus 1, it is equal 19 over 9. Not repeated decimals can't be written. Here we have not repeated. The not repeated decimals are not rational numbers. So rational numbers are, we have first one, it is the natural numbers, they are rational, the integers, the decimals, and the repeated. not repeated are irrational numbers. We will see them in the next video.